based on the date that we have. Here I have a discharge value for this a special event. I will copy it and then choose these rows and Control V. Now we have these data. We have in this window flow hydrograph. We have to be aware about this option. Energy grade, slope for distribution, flow along boundary condition. When we it shows how the value of flow distributed along the boundary condition. If you consider it 0, the flow will totally distributed along your boundary condition. But if you change the value positive, it will not distributed in the same way. But usually we will consider it as this value, and then when you put these values, then you can click on OK, and then we have to set another boundary condition, which is usually can be considered as a normal depth, is the value of a slope in downstream. And based on your model, based on your simulation and geometry, you have to measure the slope in downstream and then put this value. For example, for me the value is 0.01, and then we will OK and save the unsteady flow data. I will call it my flow, and then click on OK and close this window. The next step would be defining the value of parameters for running, and we have to consider that we don't have sediment, so we don't check this option. Then the starting date of my event 1 was 2017 first. OK, and then 13th of 2017, so 13 days. And computational intervals, the point is that when we try to choose a smaller computational interval, the model would be more precise and we have a higher computational cost. So I don't want to choose a small computational interval. In this way it takes many times, so I choose 15 minutes. And the mapping output, I try to choose 30 minutes, and then 15 minutes, and here 30 minutes. And we will save this plan with and we call it plan, and then OK. OK, and then we put compute. There is an error that said that upstream time series data starts after the simulation starts. So we have to correct this. The problem was here when we try to open our boundary condition again, we can see our time for simulation and our time for hydrograph is 2nd of September. However, in running model, it was started from 0, 1. So we change it to 1, and then OK, and file, save unsteady data, then close it and go to the unsteady flow analysis. And now we compute. Now we don't have this kind of error, but our error is changes. It said that mesh has some problem, so we have to change our mesh. We close this and also this. We go to our geometry. We will choose this one and edit and generate computational points. We choose, for example, larger mesh like 100 and 100, and then generate points. Yes, okay. Then goes to tool, go save it file, save geometry data, and then close it. Go to GIS tools mappers, and then you will open 2D flow and right click on it, compute this one. Then we will compute, and in this way we don't have any problem. Save it and close this graph and go to the analysis again, and now click on compute to see what will happen. Now we don't have any error and our model is run very well and very fast because the size of mesh is huge. And we will see, because our mesh is huge, we have such a kind of error, so we have to change the size of mesh again. It is not error, but it doesn't show the result very well. If we go to the RAS mapper to check the results, we can see the results here, and then maximum depth, you can see it is very bad because the size of mesh is really huge. So we close this one, we go to the geometry again, and then try to choose another size for the mesh. Right click, edit 2D. Here I want to choose 20 and 20, then generate points, and yes, okay. File, save geometry data, close it, and then go to GIS tools, RAS mappers, area, and then compute. It is okay. File, save, close it, and then go to this option. Now everything I think is okay, and now I click on compute to see. Okay, I decrease the size of mesh, but I see this again. I think we have to set our parameters in analysis part, so I will close it and then click on these 3 points and go to advanced time step, adjust time step based on current number, and then the value which is suggested for this it would be 3 based on different research. I put these values, and then 4 4 4, and then okay, and file, save plan, and then now we put again compute to see what will happen. The running is done, and we have to wait until the model finished. Well, the computational time is finished, and now we can see after setting the current number we don't have any error and everything is good. Now I want to talk about the current number. Current number is a number which helps us to have more stable running progress and running computational operation. When we solve the problems and we solve the equations, current number helps us to have a convergence result, not divergence, and because of that it is important. Now I think everything is okay, and if not, we can correct the errors, and we will save our model, and then we will see the result in this way. Here I want it shows the maximum flood, but if I want to see how the depth changed during the time, I can click on it, and then click on the screen image, and we can see how during the time water and the elevation and the depth is changing. And for example, especially at the time of flood, what will happen? You can see how water move during the time and how it expand during the time. Also, we can see the changes in velocity, and it is the maximum velocity, and when we run the changes in the velocity, we can see how it changed. Basically, at the time of 20 of September, we have a very intense flood. Now we can see if there is a flood. Yeah, you can see here, we see the flood by turning on the different layers. If we have city, we can see how flood covers the city and expanded, and different other parameters. uh, we have to know that this model is some initial model. It is not I want to just show you how we model the flood, and just the concept. It is really important for you to know, uh, provide a very exact model, provide a very exact data. You have to do evaluation to see if your model works well, and basically all of these are important. If you have any question, please leave your comments for me, and then we will discuss about it in next session. Maybe I try to add precipitation as a boundary condition, and then in another works I will add other parameters. Maybe in this way we can simulate evapotranspiration to see how it affects flood. Thank you for your attention, and I'm waiting for your comments.